Hello, this is my second lecture on differential equation for third sem honors and DSC students. Today we are going to study the total differential equation. The total differential equation can be written in the form P dx plus Q dy plus R dz is equal to 0, which satisfied the condition given. Now, we apply uh, three rules in this. The first rule is first integrate the equation P dx plus Q dy is equal to 0, treating z as a constant. Now, rule 2, making exact by rearranging the terms. Then third rule, homogeneous method. Here, now we going to solve one example. See here, y plus z into dx plus dy plus dz is equal to 0. Here we take p as y plus z, q as 1 and z r as 1. So del p by del y, del p by del x, del p by del z all are calculated as shown. Now, hence the condition for integrability. So this should be when it is P is related to actually here P dx. So here Q and R, if we take Q and R leaving P, and then the denominator Q is replaced by dz and R by y. Similarly, when Q, then after Q comes R and then P, R and P, and the denominator for P is X, for written below del R by del X and del P by del Z and so on. After substituting these values, if this values comes to 0, then we can say that the condition of integrability is satisfied. If the condition of integrability is satisfied, then we proceed as further. Then we take z as constant, here x as constant, so that dx is equal to 0. Here, because coefficient of y, dy and dz are separated, no variable is attached with it. So no variable is attached with it. So we here take dx is equal to 0. Now we take dy by taking the dx equal to 0, we get dy plus dz equal to 0. So after integration, we get y plus z is equal to a constant. So differentiating y plus z is equal to taking y plus z is equal to 5, we say that dy plus dz is equal to d5. Now substituting these values in equation 1, we get the equation del phi by phi is equal to minus dx, that is log phi is equal to minus x plus c, and from this we get the value of phi. Now the method 2, you can see that here it is written dx plus dy plus dz divided by y plus z is equal to 0. So by inspection, we can do this, and then integrating it, we get the value. Now, the second problem example we have taken here, y square plus yz into dx plus x square plus zx into dy plus y square minus xy into dz is equal to 0. Here in this case, variables are attached with dx, dy and dz. So we may take any one of them as 0. Here we take z is equal to dz is equal to 0. Let us suppose we can take dx, dy, but let us suppose dz is equal to 0. Z, that is z is equal to constant. So after calculating it, we get dx by x plus z minus z by y plus z into dy is equal to 0. Now again z by y plus z partially after partially separation we can see whatever comes in this, and then integrating we get the result. Here we say y into x plus z divided by y plus z as constant equal to 5. So phi may be regarded, so this one is phi, then integrating it we get u by v method. So u plus v square, that is y plus z whole square at the denominator, and then differentiating it we get whatever you can see, and this is equal to d phi, and then substituting the values we get the value. So here phi is constant, hence y into x plus z divided by y plus z is equal to phi is constant, hence the result. So method 2 you can follow. The method 2, it is given on your screen. Next, solve 3x square dx plus 3y square dy minus x cube plus y cube minus plus 2 e to the power 2x dz is equal to 0. Here also we take dz is equal to 0. So we get 3x squared dx plus 3y squared dy is equal to 0. After integrating, we get x square x cube plus y cube is equal to constant, say 5. Now then, differentiating both sides, we get 3x squared dx plus 3y squared dy is equal to d phi. Now comparing with the given equation, we can write d phi is equal to x cube plus y cube plus e to the power 2x dx, and after calculating it, we get d phi by dz minus 5 into e to the power 2z, which when we integrate it, that is integrating factor is equal to e to the power minus 1 dx. Then by applying the rule of differential equation, we can get the value whatever you can see in your example. Now take another example. Yz into y plus z dx plus zx and whatever same. So, then here we see that y plus z divide throughout by xyz. In the first case yz is there, x is missing. In the second case zx is there, y is missing. So dividing throughout by x, y and z, we get the identity as given. So again dividing y plus z divided by x. If I um, uh, add it by 1, then after addition it will in the numerator we will get xy plus z. Here also if I add in place of dy, if I add 1, then it also becomes xy and z and so on. So adding 1 and subtracting 1 in these cases we can see. and then we can see, and then whatever is on your screen. So ultimately we find dx by x plus dy by y plus dz by z is equal to dx plus dy plus dz divided by x plus y plus z is equal to 0. After integration, we get the result. Another example, dx dy plus x plus y plus z plus 1 into dz is equal to 0. Here we also take dz is equal to 0 and dx plus dy plus dz is equal to minus of that one. So by inspection, this is the inspection method. By inspection, dividing it by x plus y plus z, and then we get dz. So log of x plus y plus z is equal to minus z plus c. So this is the result. Now take another example. Solve y dx plus x dy into a minus z plus xy dx is equal to 0. So by inspection we can see that y dx plus x dy, when we divide it by xy, which is on the right side, we can write it as this way: y dx plus x dy divided by xy plus dz by a minus z is equal to 0. So this after calculation becomes dx by x plus dy by y is equal to dz by a minus z is equal to 0. Integrating, we get log x plus log y minus log a minus z is equal to log c. So after calculation, we get xy is equal to c into a minus z. Take another example. Solve yz plus xyz into dx plus zx plus xyz dy plus xy plus xyz dz is equal to 0. After inspection, we can see that xyz and xyz are also with dx, dy and dz. So dividing throughout by x, y and z, we get 1 plus x by x dx plus 1 plus y by y dy plus 1 plus z by z dz is equal to 0. And after that it becomes dx by x plus dy by y plus dz by z plus dx plus dy plus dz is equal to 0, which on further calculation gives log xyz plus x plus y plus z is equal to c. So this way we can solve this type of total differential equation, but mind it, it is in the form p dx plus q dy plus z dz is equal to 0 when P, Q, R are find out from the equation, and then it should satisfy the integrability condition. So condition of integrability is satisfied when P del Q by del Z minus del R by del Y plus q into del r by del x minus del p by del z plus r into del p by del y minus del q by del x. When this comes to 0, then only we can proceed for this type of equation. This type of equation can be proceeded further. So thank you today this much only.